Hey there, folks. Hope things are going well. This is Scott. We are going to be talking about direct and joint variations, proportions that are directly related to each other. This is from section 8.2, begins on page 357 in the book. And we're going to take a look at these here today. First of all, when you're talking about variables that are directly related to each other, as one value goes up, so does the other value. So, in other words, if you're talking about the number of hot dogs that you buy and the cost that you have to pay, well, as you buy more hot dogs, you're going to have to pay more. So those are direct variables. As one variable goes up, so does the other variable. Uh, Costs of different items that way. The taper of a rod, I think, is one example that they use too. How far you can travel, and how much gas you use, and so those are all directly related to each other. And so as one variable goes up, so does the other one. So when you go to set these things up, excuse me, what you can do is you can set up your examples. For example, how did I get that on there? Sorry about that. All right. A couple different ways that you can set these up, and in this unit, it kind of takes a look at different things and kind of runs through there in some different ways. But I think if you consistently set them up the same way, it's going to help you out a little bit more too. For example, if you look at question 1, it says you have 7 cans of dog food, which sell for $4.13. How much will 10 cans sell for? Well, if you have a direct variation, a direct proportion here, when you go to set them up, you're going to have those two variables, the 7 cans for $4.13, directly above one another. So you're going to have, here's where my pen goes. 7 cans and $4.13. Okay? And you want to know how much 10 cans is going to cost. Okay? Now, the nice thing is these have to be equal to each other. So what you do is you cross multiply, and then you can divide by the number in front of the variable. So in other words, we're going to take 7 cans times x. Okay, so we've got 7x. And we're going to take 10 times $4.13. So if we multiply that out, we're going to get $41.30. Okay, now with the things you've been doing, to solve this, you just have to divide each side by 7. Okay, so we take 4130 divided by 7. 535. Excuse me, 63. Got my decimal point there. 9. 6300. Okay, so when I do this, I know that x, my value of x now, is going to equal to $5.90. So if 7 cans of dog food is $4.13, 10 cans of dog food is going to be $5.90. And that's kind of the things that you're going to be setting up here. Like I said, whenever you're working with a direct proportion, you want to set those numbers up directly above each other. Okay? That's what you're going to need to do with that. We're going to talk about something a little bit different in section 8.3, but in this one, that's what you need to do. Let's take another one. We'll just pick one here real quick, and let's see. Hold on one moment here, folks. The other thing to keep in mind with this too, folks, is that as you're doing this, you gotta see if answers appear reasonable too with all that. So that's the kind of piece here too. Let's pick another one out here too. Oh heavenly! Oh, gracious sakes! I went down too far. Here's another one. Person weighs 185 pounds. Begin 15 milligrams of medication. If the dosage is 15, or how many milligrams of medication if the dosage is 15 milligrams for every 10 pounds. Okay, so as we're going to go do this when we have 15 milligrams and we have 10 pounds. Okay, so as we go to put this over here, we have to have pounds and pounds, so you have to put this pounds down here, 185 pounds. Okay, and so now we're still solving for x. Now, once again, direct proportion, so you multiply 15 times 185 is going to be equal to 10x. Okay, so we got 185 times 15. Then we got 5 carry a 2, 2 carry a 4, 9. And then we have 185 again. And so we have 5, 2, 7, 1, 2. Okay, so we have 207. Oops, that's wrong. What happened there? All right, 2,725 equals 10x. So we divide each side by 10. Divide each side by 10. And so we're going to have x is going to be equal to 272.5 milligrams of whatever that medication is. So that's kind of how this works. The one thing to keep in mind when you're working with a direct proportion, and really proportions in general here, but you've got to have consistency with where your labels are. I think that will help you with things as you go along too. I'm going to kind of write in the middle of the page here. But if I like to have it so, like in that last one we had pounds, pounds over milligrams, and then my labels on this other side would be pounds over milligrams. And so I have my one ratio and my other ratio set up the same way with that. And see, so then when you're trying to find the missing one, you know, oh, if I'm looking for pounds, that has to be across from here. Oh, I'm looking for milligrams, so that's across from there with all that. So those are some of the things to kind of keep in mind with that too, as you work on that. So one other thing that they talk about here at the end of the chapter, kind of, they just kind of seem to throw it in here a little bit. Oops, I don't want to save that. I'm going to go back here. I just want a new page. There we go. All right. One other thing they talk about here towards the end, and really everything that they talk about here is a direct relationship. You can set them up the same way, but at the end they talk about multiplying some 3 different things together. For example, they use simple interest, which is interest equals principal times rate times time. Okay, and so it really isn't anything with ratio or proportion, I don't think. And that's on page 362. Equals principal rate times time times principal. Okay. And really, when you solve this, you can kind of make it into a ratio that way with all those things. But for the most part, that's just kind of an equation that you need to solve with all that too. And they've got a couple different ones in there. So, but once again, these are all direct variations, direct relationships, because as one number increases, the other number increases too. So for some more work on this, I would look at page 363. We did a couple examples on there already, but look at from 1 through, oh, how many sakes? Oh, there's a lot on here for this one, through 52, and make sure that you got a good understanding of these, because the next one we're going to look at indirect relationships. And so those are some other things that you're going to need to keep in mind with all that too. So if you have any questions, make sure you let me know. Have a good one. Bye.